Welcome. So yes, today's talk is about fuzzy facets. So a lot of you will be familiar with faceted search and the idea of how you use that to refine your searches. What I wanted to talk about today was how we can use clustering as a form of faceting and allowing people to refine their searches, and how binary vectors have been sort of instrumental in enabling this feature. So a little bit of background about myself. I was an early Lucene contributor. I was working on various Lucene contributions back when it was on SourceForge, which was many years ago. I went off and worked for a company developing commercial search software where we had the audacity to ask people for money for search engine technology. And they kept asking us, well, why are you asking for money when Elasticsearch are giving us this stuff for free? Which was a very good question. So I couldn't answer that, so I ended up joining Elastic and was employee number 30, so quite early on during the development. And I worked on the core search engine while I was at Elastic. And when it's not sunny, I'm now tinkering on hybrid search interfaces. So I'm mostly semi-retired, but still dabbling with things of interest. So my interest really lies in search as a conversation. So this sort of loop that we have of we type in a search and then we discover something new and then we refine our search and we go around this loop. And a lot's happened in recent years, as you're probably very well aware. So traditionally we would type keywords into a search box, maybe use a bit of Boolean logic to connect these terms together. Then along came faceting. So we had things like checkboxes appearing alongside our search results, saying, do you want results from Department X, Department Y, brand X, brand Y? And people would interact and narrow their searches using those sort of things. And now we have vectors. So we have the ability to take text and represent it as arrays of numbers and match things in ways which text just can't achieve or get close to. So it's a very powerful technique. And we have all of these different things open to us and available to us. And the examples that I've used in this slide here actually come from a patent search. These are actually 3 different ways of saying exactly the same thing. You can search for a dog lead using keyword search. You can have a vector representation of something that's akin to dog leads. And you can also use structured codes. So with patents, they have things called IPC codes, CPC codes. So there's a huge taxonomy of all inventions in the world, and they try to assign codes to things. And in reality, in practice, you want to use combinations of all these things. And one of the things that I've found is Elasticsearch is one of the best things out there for doing this. So I've tried to use vector databases to combine these 3 things together, or 3 or 4 things together. And a lot of the other vector databases, bar one, they assume that the vector search is perfect. And then the next question they ask is, how can I show you less results? So how can I use structured codes and filters to narrow the set of search results? Not how can I show you more search results by ORing other criteria. It's always a filter, which I think is one of the big restrictions. So vectors are nice, but they aren't always perfect, and we need to augment that by having alternative search phrases or terms and codes alongside the vectors. So we'll see examples of that in the demo. So how do we use clusters in practice? Well, this is an example here of the latest news articles. So the demo that I've got today is based on news data. And you can see a little slider along the bottom there. So I have dynamic clustering. So if I slide the slider all the way over to the left, then I end up with one very broad category, which contains all of the documents, the latest 200 news articles. If I slide it all the way to the right, I get very, very specific clusters, typically clusters of 1, unless there's an identical piece of text, and then they form a cluster. Somewhere in the middle is the Goldilocks kind of sweet spot. That's where we get clusters where we get news articles that are related in subject matter. How to cluster them? So you're obviously aware that vectors are designed to be compared, and you can compute a similarity between 2 vectors. So 2 different documents, they'll each have a vector associated with them. And if you're using floating point vectors, you have arrays of numbers. And there are various different similarity measures that you can use to actually compute a score between pairs of documents. If you're using binary vectors, so that's a much more compact representation of the floating point vectors, you only need a 1 or a 0 to represent each number. And that uses a different comparison metric. It uses Hamming distance. How many bits do these things have in common? So those are sort of the foundations of clustering. When you have these search results, you can use these computations to determine what documents go into which clusters. So why am I an advocate of binary vectors in particular? Well, they're very, very small. So if you compare the size of a floating point 32-bit embedding that's got 1,536 dimensions, which is the model that I'm using, that will take about 6K to represent one document, whereas the binary representation is only 192 bytes. So these are small enough to send down to your clients in volume. So you can have so many hundreds of search results, and with each of the search results, you can send down one of these binary vectors just as a bunch of bits. And they're very quick to compare. So my iPhone 10, back when I had an iPhone 10, could do this clustering very, very quickly with no lag whatsoever on very large numbers of search results. And the quality typically is good enough. So in my experience, I've not benchmarked it or anything, but I've never had a false positive in the data that I've been looking at. I've been clustering, and when a score is over a certain threshold, you can pretty much bet your bottom dollar that those two documents are talking about the same thing. So it's quite a reliable quality metric. So putting this into practice, how do you cluster your search results? So it's a 3-step operation, which is essentially graph trimming. So in your search results, every document is connected to every other document to some degree. So that is step 1. What you do is you compute a similarity score between every document pair in your result set. That gives us, in my diagram here, a line connecting one document with another, and the thickness of the line is intended to represent the quality of the score. So step 2 is to remove all the lines below a given threshold. It's your choice of threshold. So if you set the slider somewhere in the middle, then you're going to get some reasonable quality results, and all the dotted lines in that diagram you remove them. And then the third step is simply to figure out how many clusters you've got left over. So in this case, we would have 2 clusters if we removed all the dotted lines, because the 3 documents at the bottom are still connected and the 2 documents at the top are still connected. And that's the basis of how you compute clusters in the client. And you can do this using JavaScript. You can ask ChatGPT to generate the code for all this. And it works very, very quickly. Now, special trick. Once you've got your clusters, you then will typically want to act on that. You'll want to say, well, let me drill down on that. Let me focus in on that particular subject here. So one of the clusters in the latest news here is about Trump sending Venezuelans back to Venezuela. And there are 4 documents that talk about that subject matter. Now, if I wanted to drill down on that, I could do a query to Elasticsearch saying, find me documents that either have vector 1, 2, 3, or 4. But that would be quite expensive, because vector search is expensive when you're doing it against millions of documents on disk. So although Elasticsearch would cope perfectly well and give you the right answer, it would take a long time computing that, because it's got to do an OR and do 4 sets of calculations for every single document that it's going to look at. A curious thing about embeddings is that you can merge them and still retain an essence of what they were all talking about. So you can take these 4 vectors here, and you can compute an average. So on average, was bit 1 1, or was it 0? And you set accordingly. When you compute an average embedding like that, it's perfectly usable and functional and represents the merging of those concepts. So again, you can do this in the client and then use it as a query topic. Now, I was a bit mind blown when I first saw this, and because I can see somebody going, what the hell, how does that work? And I had exactly the same reaction. So what I wanted to do was I wanted to see what the search engine was using. I wanted to see the ones and the zeros. So I actually started visualizing the pixels behind this stuff to see what happened when you moved the slider and how they jumbled up and everything else. And I actually then found that quite useful because I wanted a tangible representation of that concept, that query that I've just pulled together, the 4 documents that got merged together. I wanted something that I could pick up and drag and then drop. And then I started thinking, well, actually, this might be useful to other people because it's actually a representation of what's happening under the covers that's tangible and visible. And it's somewhat like QR codes. So I've got what I thought was a QR code on my badge here, and as all of you have. It's actually not a QR code, but we do understand implicitly that that's not something we're supposed to understand and read, but we know something can read that. I haven't found out what it is yet. Maybe it's a beer. Is it?
I think it's an ID for the person, because it's just like a list of...
So what scans this, do you know? Carly, do you know? Do you know? We don't know what they do, but we know this has utility, right? Okay, so it does something, right? So a machine somewhere understands this, right? And that's what I wanted to do with these codes, is I wanted to put them in the user interface, just so people would know that this is something the machine understands, and I can give it to it, and it will do something with it. Hopefully give me a free beer, but if not, then maybe some search results. So with that in mind, because these things are so useful, you can drag them, you can merge them, you can label them, you can copy them, put them in clipboards, send them to the search engine. I actually wanted to start making this part of the search conversation, because we've got keywords, we know what they do, we know what ands and ors do, we've got checkboxes, we know what they do, but we've got this new part of the search conversation, which is these query codes, or what I've chosen to call query codes. So it's QR with a Y, so query codes. So I put together a little website which is kind of user-facing. So if you choose to put something like this into your search interfaces, then there's an explainer. There's a website you can point people at and say, this will tell you what a query code is and how magical it is and what sort of properties it has and how it's different from QR codes. So one more place where we can form these query codes or vectors and fusing them together is through RAG. So I can take my set of search results, I can send however many 100 articles off to an LLM somewhere, and it can chew on it and spit out a summary. And more often than not, what I want in the summary is a set of citations. So something that says, yes, this assertion here that in the LA fires, people were impersonating firemen and looting is corroborated by documents 19, 20, 25, and 42. So click, I want to see those documents. And then, if I'm interested in people impersonating firemen and looting, I can pick up that query code and drag and drop it into my query. So let's see that coming together in this demo. So what I have is a small set of fonts, so maybe I'll make that a little bit bigger for you. I have 1.5 million news articles, and they're constantly updating. And I've been doing it for a little while, since 2019, so I've gathered all these documents, and I've now run them through an embedder. So every single news article has a vector embedding associated with it. Now, obviously, you're familiar with the idea of sorting by date and all those kinds of things, but grouping by topic is this clustering thing in action. So that algorithm that I showed you a minute ago is working here. So if I move that slider here, we're reclustering on the fly. So we've set the bar very, very low in terms of our threshold, and everything got lumped into one category. So these are the latest 200 news articles. If I slide it all the way over to the right, then we get lots of individual clusters, and somewhere in the middle we get something useful. So if we look at the first one, the Bank of England signals further easing after rate cuts, pound plunges after Bank of England cuts rates. So those are all about the Bank of England cutting interest rates. That's just happened. Stuff to do with Trump and Gaza, stuff to do with the school shooting in Sweden. So this is where that query code comes in and where I wanted something tangible. So I can pick that up and drag it into my query builder as a first level of filtering. I can then add subsequent filters here. So the way this works, my query builder works by chaining things together. If you go horizontally across the page, it's an and. If you put things underneath other blocks, it's an or. So it's a simple kind of Boolean query builder, but it can have arbitrarily complex Boolean queries in there. Again, I get a set of 33 search results back here, so I can do various things with those. I can then, again, subdivide by topic. So these are all naturally clustering into one topic here, but again, I can subdivide clusters here. So we're doing a cluster of a cluster, as it were. The other thing I've got going on here is connection with LLMs. So I've got a raft of various different LLM models that I can send this stuff to. So if I said summarize the results of all these documents talking about these school shootings in Sweden, we would get the LLM's view of how that panned out over time. So this is a summary of all the various different articles that are going on here, talking about the location, the campus, the number of casualties, country's worst mass shooting. So each time there's a cluster of citations, I can click on those, see the individual documents, and again, because we can fuse all these vector embeddings together, if I wanted to drill down on that particular aspect of the story, I could perhaps put it in another tab and then open up a new line of inquiry. So that's our LLMs helping summarize the data. Let's go back and do another query just to illustrate how keywords search and vector search can be combined together and how you might interact with them. So this time what I'm going to do is I'm going to start with a keyword search. So I'm going to search for bird flu. And we've got a decent set of results. It wasn't an ambiguous query. It's pretty much cohesive set of results. We can still group them by topic, and we can break them down into various focused clusters. What I want to do here is illustrate how even when you take 200 articles, if they're all about the same topic roughly, I can still fuse 200 embeddings together on the fly in the client and come up with a new query. And it still makes sense. So let me drag that into my query builder. So we're now looking for documents that match that vector, that fused vector, and the word bird flu. I want to know what that vector embedding might be matching other than bird flu, because there is a danger it might be overmatching, right? So I'll go to my original search term and I'll say take it away. Exclude any document that contains the keywords bird flu. And this is a way of me checking that this vector is doing the right things. So what other garbage did it match? So I could actually scroll through all the matches here looking to see what it's matched, or I can try and type in another keyword phrase here. And I'm using Elasticsearch's significant text algorithm. So that's the thing that I added which looks for unusual or uncommon phrases in your set of search results. And you'll notice that it's come up with the phrase avian flu. So if I click on that, I can now drag that and I'll put it underneath bird flu in my exclusion list. So say, what is this thing matching if it's not matching bird flu or avian flu? And the answer is nothing, which is a good validation of that vector search term. So we fused 200 vectors together and it didn't match anything other than bird flu or avian flu, even though I didn't use the word avian flu in my original search when we created that cluster. So these things have a lot of utility, I think, and part of interacting with them makes me want to actually make them more tangible and representable and understandable to end users. So in summary, binary vectors are fast enough and small enough to send down to your clients and do clustering on, even on mobile devices. So clustering provides a flexible way of grouping content. So rather than having to do the equivalent of what the patent office were doing with their big ontologies and taxonomies, assigning things into various different cluster codes and things like that, or category codes, you can compute clusters on the fly for things that you've perhaps never even considered grouping together before. My assertion is that users need to be able to combine keyword structured and vector clauses in searches in flexible ways. So even though that vector clause was doing a good job, if I added the bird flu and avian flu underneath the vector as an alternative search term, I would find even more documents. So a lot of vector databases out there will actually say you can only do a vector database and then filter, see less results using other criteria. One of the beauties of Elasticsearch is that you can actually put things together arbitrarily, and that's part of what I've been trying to do with the graphical query builder, is to actually have a language for assembling stuff in arbitrary combinations. And these QRY codes, basically, I haven't invented anything new. I'm just trying to give a user-friendly term to something that otherwise is quite abstract to end users. When we talk to them about semantic search or embeddings or vectors, you can actually see people's eyes glaze over. But if you tell somebody it's a magic code and you can use it, they go, oh, okay, fine. Actually, I have one actually piece of complexity to my query codes when I have them. I have a slider to set the quality threshold for the match. And that's as complicated as people need to get in terms of how they interact and use these things. So that's the conclusion of my demo and my talk. So I'll be open to questions if you have any feedback as to whether you think these ideas are useful. That'll be all useful stuff for me. Thank you.
Thanks so much, Mark. We have time for one question, so is there a hand up anywhere? Yeah?
Hi, yeah. First of all, I want to say that's some insanely cool stuff you've built. So super impressive.
Thank you.
So I guess coming from a kind of a security background, do you think that this sort of vector clustering could be used against log sources that we're looking at, and then maybe to identify anomalies in those log sources by clustering together similarity and then highlighting where things are outliers, essentially?
But I think one of the interesting things with the LLM is search when you type using Elasticsearch is basically testing the properties of a single document. And it's saying, does this document contain the search terms that I'm looking for? And I realized some time ago the limitations of that when I was developing Elasticsearch. And I became an advocate for what I called entity-centric search, which was don't just index events, logs, but actually start to fuse data together around an entity. So maybe a session ID, or a person, or a product code, or whatever. Start to build searchable units that combine multiple elements, and that ultimately sort of led through to the Transform API. So that's what that is trying to do, and fuse those things together. I think what's interesting about LLMs, when you give them content in a sort of RAG type context, is they're able to do that thing of looking across multiple documents and then coming up with, being able to reason about that, sort of join the dots up and then answer certain questions. Oh, that does, yeah. I was going to demo it. I haven't got time now. I think, how are we doing for time, by the way? -4. Damn. Okay. And another cool thing with the LLM that I discovered was when you get something like, the Sweden, no, the bird flu outbreaks, right? So I've got a raft of all the bird flu things. One of the most interesting questions that I asked the LLM was, what questions should I ask about this data? Because you can give it all this data, and so how would you, summarize this stuff? What tables would you put it into? And it actually comes back with stuff like, well, you can organize this by the various different strains of bird flu that I've identified, which countries got them first, and how they're coping with it, and all that sort of stuff. So it actually suggests various different ways you can formulate those responses and then put them in tables. And that clearly is sort of looking across multiple and reasoning about multiple events. And it's really cool, you know, that you can do that. Some LLMs are better than others at doing that, but some of the prompts you get back as suggestions as to how you can take this set of disparate events and then present them back in tables and things, it's insane. We'll show you examples of that later, you know, catch me up offline if you want to see that stuff. Thank you.